Yeah, good afternoon all. We are back with our class on graph. So we yesterday studied that there are two kinds of graph, distance time graph and velocity time graph. Distance time graph is written as ST graph and velocity time graph is called as VT graph. In both distance time graph and velocity time graph, time should be taken in x-axis. Time is always measured in seconds. And in distance time graph, the distance or displacement is taken in y-axis, and in velocity time graph, velocity is taken in y-axis. We studied when the body moves with a uniform speed, it always gives you what? Or when the body is in uniform motion, the distance time graph is always a straight line passing through the origin. When you have a body which is moving with a uniform motion, or when it shows uniform motion, how do we calculate speed from this graph? Okay, so let us write now the second part of the same graph. Please write to calculate speed using distance time graph. To calculate speed using distance time graph or using ST graph. Okay, so please understand, I am going to show you few pieces of graph sheet which Hanan has brought. So like this only you have to cut it into small pieces and draw your graph and stick it along with it in your notebook. You can draw the plain graph what I am showing. Also draw graph on the graph sheet and write y-axis as distance, x-axis as time, and then draw the graph and stick it. Okay, so do it like this as she has done. Now coming back to calculate speed using distance time graph. Now when we have graph ಮಾಡಿದ್ವಿ, we had taken what? Time and distance. What was our time? We took 0, I think 1, 2, 3, 4, okay, 0, 1, 2, 3, 4, 5. Only till 5 are left. Yeah. Now I take here what? 2, 4, 6, 8, 10. This was my graph, and then we got what? We got a straight line passing through the origin. Okay. Now let us suppose I say I need to find out the time, or I need to find out the speed. So to calculate speed, the first thing is I should know from which time interval to which time interval. Let us suppose I say calculate the speed between 2 seconds and 5 seconds. I say what? Calculate the speed between what to what? Between 2 seconds and 5 seconds. So what I will do? I will plot a graph, straight line from 2 seconds. And then what I will do? I will plot a graph from, 5 seconds. Correct? Understood? Now, let us suppose when I say this, I can write it as what? 2 and 5. Fine? So now, let us suppose I say in this graph, I will find this point as point A and this point as point B. And I say calculate the speed of the object when it is traveling from point A to point B. Yes? Understood? So now what I will do, I will also draw a graph like this or a perpendicular like this from this part. So now these two meet at what point? At this point. Clear? So this becomes a triangle which is what? Triangle A, B and C. Yes? This is point, A point. Let us suppose the time is what? T1, and at point B the time is what? T2. Correct? Now the distance, let us suppose, I will change this for easy calculation. Let us suppose this distance is what? 4, and let us suppose this distance what I take is 10. You can measure and draw by drawing. So this becomes what? S1. This becomes what? S2. what? The speed of the object. Okay. So always understand, if I plot a graph with time in x-axis and distance in y-axis, and whichever points they tell me, I have to draw perpendicular on the x-axis, I have to even draw perpendicular on the y-axis. Then whichever is the perpendicular, I have to continue till what axis? This y-axis. I will get what? A triangle here. The slope of this triangle or the hypotenuse of this triangle gives me what? The speed. So how is the question asked? What does the slope of distance time graph show? The slope of distance time graph always shows what? Speed. Yes. So first draw this graph. You can pause it, Kachana. So the one thing what you have to remember all your life while calculating the slope of any graph, if I have to calculate the slope of any graph, it always has to be what? Vertical distance by horizontal distance. So BC by AC. This will give me the slope of the graph. So remember, objective type questions or any questions when they ask about the graph, you should know that the slope of the distance time graph gives me what? Speed. Slope of the displacement time graph will give me what? Velocity. Speed distance time graph gives me speed. Displacement time graph will give me velocity. Now for the next one, please write the final line there. The slope of the distance time graph gives the speed of the body. Why I did not dictate this? The notes of this chapter has been posted to you. You can check from there and write. Okay. Now for the slope of the distance time graph gives the speed of the body. Now we talked about what motion? Uniform motion. Now we will draw a graph for non-uniform motion. Is right? ST graph. So is it clear? First what we studied? ST graph for a non-uniform motion. ST graph for uniform motion is always a straight line passing to the origin. What does this slope indicate? The slope of a uniform graph gives us speed. If I have to calculate the slope between point A and point B, what should I do? I should put a perpendicular to x-axis, perpendicular to y-axis. Again put a perpendicular to x-axis, put a perpendicular to y-axis. Extend this perpendicular to this. I get a triangle what? ABC. How do I calculate the slope? BC by AC. This gives me the slope of this graph, which is called what? Speed. The slope of displacement time graph will give me what? Velocity. Now I have to find out ST graph of a body moving with non-uniform motion. Please write. ST graph of a body moving with non-uniform motion. So what is non-uniform motion? When a body covers unequal distances in equal intervals of time, or when a body covers equal distances in unequal intervals of time. Okay, did I say the same thing? Twice? No. Okay, so now for the non-uniform motion, we may have non-uniform motion when the speed increases or when the speed decreases. So first A will write for increasing speed. When the speed of the object increases, like that is, let us suppose its speed when it started was 0, but slowly it reached the speed. So ignore it. This is my x-axis. This is time in x-axis or time in second, and this is what? Distance in meter. Correct? I am not drawing any graph with 1, 2, 3, 4 and all. This is just a depiction. See, if I get a graph like this means what? The speed is increasing. See, here the passing of time, what is happening to the speed? It is constantly increasing. So this is a graph of non-uniform motion with what increasing? Speed increasing. Let us write this graph as what? OA. You don't need to draw these lines. Is it clear what I have drawn? So this is a graph of what uniform motion? Non-uniform motion. But what is happening? The speed is increasing. Please draw this for increasing speed and non-uniform motion. ಪಕ್ಕದಲ್ಲೇ ಮಾಡ್ತೀವಿ ನೋಡಿ ಈ ಗ್ರಾಫ್ for decreasing speed. Same, you have 8 and 10. Okay. So now please look here first. Then you can draw it. I'll give you time. When it was 0 seconds, where was the object? At 4 meter. When it was 1 also, he was at 4. When it was 2 also, he was at 4. When he was 3 also, he was at 4. When he was 4 also, he was at 4. When he was 5 seconds also, he was at 4. Huh? This one is not given. Okay. Suppose his object at rest. We'll add 1 also. Because I put 5, we'll add 1. So 6, 5 and 4. So now what we will do? This is going slanting. When you draw it, you will get a straight line parallel to what axis? X-axis. This shows the object is at rest. I am removing my points and drawing a proper line so that you can understand it. You will get a line like this parallel to x-axis. So you write 1, 2, 3, 4 and 5. Is always at what meter? 4 meter. Okay. So now speed of an object when it is at rest. The speed of an object when it is at rest is always equal to what? 0, because there is no slope of this graph. Or if I say I need to find out the speed, what is speed? Distance by time. So S2 minus S1 by T2 minus T1. S2 and S1 both are what? 4. So 4 minus 4 is equal to, suppose I take it between 2 and 4. So 4 minus 2, which will be what? 0 by 2, which will be equal to what? 0. Understood this? So always understand, for an object which is at rest, speed of the object will always be what? 0. Please write. For a body at rest, the distance time graph, for a body at rest, the distance time graph is always parallel to x-axis. The distance time graph is always parallel to the x-axis. Next point, Parvi. The speed of the body, is 0 for a body at rest. The speed of the body is 0 for a body at rest. So now we have finished everything about distance time graph. Okay, so the first graph which we started yesterday, which is what graph? ST graph. So I will revise once again. In an ST graph, always what? Time is taken in x-axis and what is taken in y-axis? Distance is taken in y-axis. If the body is moving with what motion? Uniform motion, you get a distance time graph which is passing straight line passing through the origin. The slope of this distance time graph gives me always the speed. If the body is moving with non-uniform motion with an increasing speed, the distance time graph is shown like this. If there is an object which is moving with non-uniform motion but with a decreasing speed, the distance time graph goes like this. Correct? If there is an object which is at rest, the distance time graph is parallel to what axis? X-axis. Clear? The slope of the distance time graph always gives me the speed. To calculate speed between two particular points, I will put perpendicular to x-axis, perpendicular to y-axis. From the final point also perpendicular to x-axis, perpendicular to y-axis. Then increase this perpendicular so that it touches the perpendicular on the y-axis. Both mean, let us say object moving with non-uniform motion with increasing speed. This is an graph for an object moving at non-uniform motion with what speed? Decreasing speed. All these are what graph? Distance time graph. Now, I will again draw it, but you will start telling which graph is what. 4 graphs we have studied. First, what is this? Object at rest. What is this? Object moving with uniform motion. What is this? Object moving with non-uniform motion with increasing speed. This is what? Object moving with non-uniform motion with increasing speed. What does the slope indicate?
Speed of the object.
Okay, the slope of the distance time graph gives us speed. Now we will talk about what graph? Velocity time graph. Let us take out our textbook and see how much is being done in distance time graph in our textbook. Please come to page number 104. Come to page number 104. Okay, this is graphical representation of a motion which we wrote about 4 lines. The graphs are pictorial representation of the data. They are the tools to study the motion of an object. We said that graphs are generally drawn between x-axis and y-axis. In both the ST graph and x-axis, and velocity or distance is taken in y-axis. Distance time graph, you have a graph which is of what motion? Uniform motion, and the slope of that graph, which we also studied, S2 minus S1 by T2 minus T1, gives me what? The speed of the graph. Then come to figure 8.4, you will find there is a non-uniform motion graph of the distance time with what speed? Increasing speed. I have taught you 2 more. What is one graph which I taught extra? Decreasing speed, and I taught 1 more. When the object is at rest. Here, when the object is at rest, its speed is 0. You can go back home and read through whatever has been there. If you have understood this, you will very easily understand what is given. Now we will start with velocity time graph. Please write the heading as velocity time graph. Write heading VT graph or velocity time graph. Do you find graph stuff or is it easy? Understood what is the basic line? That graphs are pictorial representation of data. First we will study the entire ST graph and VT graph. Then we will have to derive equations of motion from these graphs. That is, we should know from where we can calculate speed, from where we can calculate velocity, from where we can calculate acceleration. How to calculate speed? Vertical distance by horizontal distance. So the slope of the ST graphs always gives us speed. Fine. Now write velocity time graph. Please write in velocity time graph, time is taken in x-axis. Time is taken in x-axis and velocity is taken in y-axis. Velocity is taken in y-axis. Next, Parivi, the slope of the VT graph. The slope of the VT graph gives acceleration of the body. The slope of the VT graph gives acceleration of the body. What does the slope of ST graph give?
Speed.
Speed. What does the slope of velocity time graph give? acceleration. Please write. Next point. By calculating the area under the graph, by calculating the area under the graph, we can find out the magnitude of displacement. We can find out the magnitude of displacement travelled by the body at a given interval of time. At a given interval of time of displacement of the body at a given interval of time. Okay? So this is what? First thing what we studied, if the body, if we have to draw a velocity time graph, then what do? We take velocity in meter per second and we take what? Time in second. If the body is moving with a uniform acceleration, then you will get a straight line passing through the origin. So this slope gives me what? Acceleration. And the area below the graph, which is what? Area of triangle ABC and area of trapezium. Okay, this is trapezium. Area of trapezium and area of rectangle. We will study how is. So triangle plus this gives me what? Displacement of a particular object in a particular time. Let us suppose between time interval T1 and T2. So clear what we have written? The area below the ST graph gives me the displacement. The slope of the VT graph gives me what? Acceleration. The slope of ST graph gives me what? Speed. In clear it. Slope of ST graph gives speed. Slope of VT graph gives acceleration, and the area below the VT graph gives me displacement. Innonsari. The slope of ST graph, speed. The slope of VT graph, acceleration, and the area below the VT graph gives me displacement. All three things clear? Slope of ST, speed. Slope of VT, acceleration. And the area below VT graph, displacement. Okay? Now, let us do first graph. Please write A. When the object is moving with a constant velocity. When the object is moving with a constant velocity. When the object is moving with a constant velocity. If the velocity is constant, what will be its acceleration? The velocity is constant. See, what is acceleration? V minus u by t. This is what is acceleration. Okay, now acceleration will be constant. If the velocity is constant, what means what? Let us suppose I say that at 0 second, the velocity of the object was 0. Let us suppose. At 1 second, it attains a velocity of 4 meter per second. At 2, it still attains, or rather I should say 4 meter per second. 3 also it is 4 meter per second. 4 also it is 4 meters per second. So I say calculate the acceleration between 2 and 4. So what will you write? 4 minus 4 by 4 minus 2. So 0 by 2. So acceleration will become what? 0. If the body travels with a constant velocity, there is no change in velocity. V and U will both be same. So it v minus u will become 0. So the acceleration will be 0. Clear? So there will be no slope. So how will be the graph? Parallel to x-axis. Understood how to? So please write. When the object is moving with constant velocity, let us first draw a table. Please draw a simple table. What will be the column? Serial number, time in seconds, and velocity in what? Meter per second. Okay, so let us draw our thing. 2, 1, 2, 3, 4, 0, 1, 2, 3, 4. We have everywhere 5, 5, 5, 1, 2, 3, 4, 5. Please draw the table. So after drawing the table, we put it across in the graph. We have in x-axis time in second, and we have in y-axis velocity in meter per second. This is my origin on 0. So we have 0, 1, 2, 3, 4, and 5. You should always use your scale to demarcate. Don't do it like me. And you find from 0, actually we should draw 2, 4, 6, 8. We've taken before, so I'm going to miss that. So now somewhere here is my 5 velocity. So this is how it will become what? Parallel to x-axis. Because at 0 also the velocity was 5 meter per second. 1 also 5. 2 also 5. 3 also 5. 4 also 5. So the body, the graph will come parallel to what axis? X-axis. So now we have to find out the acceleration here. As I said, what is acceleration? Acceleration is v minus u by t. But here v is equal to u is equal to what meter? 4 meter per second. So we will write a is equal to 4 minus 4. Let us suppose I tell you to calculate between 2 and 4 seconds. 5 So 2 and 4. So it is between 4 minus 2. So 0 by 2, which is equal to 0. So please write 5. Okay, sorry. So it is 5 meters per second. So it is 5 minus 5. So 0 by 2, which is equal to 0.
5
so
minus 3.
5 minus 0.
3. 5 minus 3. Denominator. There only.
How? I told between 2 and 4. Okay. So between 2 and 4, it becomes 0 by 4. 0 by 2, which is also 0. So please write acceleration of a body moving with a constant velocity. Acceleration of a body moving with a constant velocity is always 0. Acceleration of a body moving with a constant velocity is always 0. We will not do much more today. We have still to calculate the acceleration of the VT graph or acceleration to the VT graph in a uniform motion. We also need to calculate VT graph of non-uniform motion and equations of motion, which we will do it in the next week. Kindly concentrate and finish off all this. Next week you will have a test which I will tell you and